So in this video, we're going to learn how to write an equation for an ellipse. So on the last video, we were learning how to graph an ellipse. If you didn't watch that one, or if some of this doesn't sound familiar, you might want to go back and watch that one because I go over a little bit more detail about the ellipses. So an ellipse is an oval shape that can be vertical or horizontal. The equation for the ellipses will depend on the orientation. So if it's horizontal or vertical, we can see those here. So for the equations, if you look down at the bottom left of the screen here, we have x minus h squared plus y minus k squared equals 1. And that's actually going to be the same on both equations. That's not going to change. What is going to change is the bottom pieces here. These have to do with either the major or the minor axes. So you can see on a horizontal ellipse, the minor axis is the one that's going across the kind of shorter distance, and the major axis is going across the longer distance. It's the same thing on the vertical, but it's switched positions. Now the longer one is going up and down, that's the major axis, and the shorter one is going side to side, because that's now this kind of skinnier part of the ellipse. So we have b squared and a squared. A squared is always the distance, half the distance of the major axis, so the longer one. So between the center and the vertice, or the vertex here. So a on this one, if it's going horizontal, since it's going right and left, that's going to be under the x squared. So you can kind of think of its x axis goes right and left. So if the major axis is going right and left, then a is under x. But if it's vertical, that means that the major axis is going from top to bottom, just like the y-axis. So now the a goes under the y. So you want to make sure you kind of make that connection however you need to remember that. The top of these equations don't change, but the a and the b will switch places depending on, is it vertical? Is the major axis going right and left? Or is the major axis going up and down? Okay, so now we're going to take a look at the problem they give us. So find an equation of the ellipse that has a center -2, 5, a minor axis of length 10, and a vertex of 10, 5. Okay, so will this be horizontal or vertical? So I'm saying horizontal, but then I'm saying, how do you know? So you want to think about it. How do I know that this is going to be a horizontal ellipse? Now, if I look at the center, it's -2, 5. Now, if you had a graph, you could definitely graph this, and that might help. The minor axis doesn't help too much quite yet because I don't necessarily know which direction I'm going with the minor axis. But I can see a vertex is 10, 5. So the y on the 5, or the y on the center and the y on the vertex match. So that means horizontal. Okay, so if we take a look at the graph, because sometimes I think this is a little easier to visualize than just trying to kind of think about the numbers. So it said we had a center at -2, 5. So if you've never used this before, it's just desmos.com and you can give it a label. So I gave it the label. So here's my center. It also told me I had a minor axis of 10, but that wasn't really helpful yet. I don't know which direction I'm going with the minor axis, but it did tell me I have a vertex at 10, 5. So if you notice, these are going right and left from each other. So that means that we're going to have a horizontal ellipse. So we're going to go 5 up and down to go on the minor axis, since the whole minor axis is 10, right? Remember, it's half and half. Okay, so you can see the y-coordinate of the center and the vertex are the same. So they're at the same level on the y-axis. I'm just moving right and left. I'm going from -2 to 10 on the x-coordinates. So if it were the x-coordinates that matched and the y's that were changing, that would tell me it would be vertical. Okay. So which equation will I use? I'm going to use remember the top is the same. It's x minus h squared and y minus k squared. It always equals 1, but it helps me decide where to put the a and the b. So the a squared is going to go over the x. Since it's horizontal, it's going right and left. So minor axis length, they told me that it was 10, right? And remember, 2b is equal to the minor axis length because it's from the center is b, but the whole length is 10, so I'm going to divide by 2. So from the center up, I'll go 5, and then I'll go 5 down. The major axis, well, that's the distance between the vertex and the center, right? So if I take 10 and I subtract 2, then I'll get 12. So 10 minus -2 is +2 here, right? I'm going to go 10 plus 2, and I get 12, okay? So this is not the distance of the whole major axis. It's actually just the A part. I should have kind of changed that. It's half of the minor and half of the major, because since this is the distance from the center to the vertex, it's only the half. The entire thing would be 24. Okay, so now I have my A and my B, so I'm just going to plug it into my equation. Remember my H and my K, that was up here. So H was -2, K was 5, and then A is 12, and B is 5, and it always equals 1. I do need to clean this up a little bit. I can't type in minus negative when I put this in Alex, and they aren't going to want you to type in 12 squared and 5 squared. They're actually going to want you to work these out just like this. So x plus 2 squared, y minus 5 squared, and then 144, because 12 squared is 144, and 5 squared is 25. So this is how you create an equation of an ellipse. I hope that helped, and I'll see you on the next video.